bad news coming up. It's really bad news. But I wanted to put these on Screencast-O-Matic so it would be out there on whatever you call that, YouTube. This week is fine. No problem this week. Next week is almost a disaster, okay, for this class anyway. On Tuesday, I have a doctor's appointment. Yeah, terrible. My hematologist only sees patients on Tuesday mornings, and my appointment's at 11 o'clock, which means I have to go for blood work at 10 o'clock, meaning I have to leave here by 9:15. That wipes out this entire class. Okay. If that wasn't enough, I don't know if any of you are involved with this. Are any of you involved with Honors and Awards Day? No? Well, I have to be. It's next Thursday, not the day after tomorrow Thursday, but the following Thursday. And it starts at 9 o'clock on the Birmingham campus. It's going to wipe out all of Thursday's class for this class. In fact, it may wipe out Thursday's 8 o'clock class too, because if it starts at 9, I have to leave here by 8:30, but that's to get there at the beginning, and I'm sure we have to be there earlier than that. And I have at least one student who's an ambassador, and she has to be there like an hour ahead, so she's not going to be here at all either. So, now. So, what we have to do now, I can't do anything about honors and awards, but I feel like it's my fault on the doctor's appointment, but I can't do anything about it either. I would like to make up that class if we could. When would be a good time to do it? No good time, huh? I know last time it seemed like maybe one person came when we did a makeup. Last time I had a doctor's appointment. Was it Kamari? Was that you? EJ. It was EJ, that's right. I don't know whether this week or next week would be better. I know for you, Tuesdays and Thursdays are the only days you're on campus, but you can't do anyway. Let me get to the last announcement, just in case you were about to say this. Next Friday, not this Friday, but next Friday of that week that everything else is happening, I have an infusion. I have to be there before 8 o'clock, so I won't be on the Birmingham campus at all on that next Friday. I will be there this Friday. Or if Friday's a better day for you, we could do it Friday. So we've got today we could do it, Thursday we could do it, or Friday we could do it. Now Mondays and Wednesdays I could do it after 3:15. So Tuesday and Thursday right after this class, and Friday anytime between 8 and 1. Does any of those times work for you? For anybody? Okay. So, what I guess I'll wait and see about EJ, since he was the only one that could make it last time, and I'll wait until Shavette and the others come in too. And if we can find any time that we can, I'll record it so you can all catch it up on YouTube. But I'd rather do it this week or next week, because the following week is getting awfully close to finals. I can still do it then. We'll work that out however we can. Okay, that's the bad news. So, any questions on anything we've done so far? All right, we had done example 7, which you see on the board here, but we didn't do example 8, but example 8's not on the PowerPoint. So what we'll do is do example 8 here. If there are no questions, then 3 times the tangent of x over 2 plus 3 is equal to 0. Okay? Solve that equation. If there are no questions, know it was a long time since we were here, at least a week and a half, but hopefully we haven't forgotten this. How do we do a problem such as that? That, by the way, is an x. It's sort of an ugly x. X over 2. How would you solve a problem like that? Now, they don't give us an interval, so we'll have to assume this is for all time. How would you begin? Subtract 3 from both sides, an excellent first step. Subtract 3 from both sides of the equation. And what does that leave us with? 3 tangent x over 2, that adds to 0, is equal to negative 3. Now what? Divide by 3, another great step. Okay, these 3's go out, and this becomes minus 1. So we have tangent of x over 2 is equal to negative 1. Now what? Now, if you haven't been noticing what Kamari was doing, he was solving first for the tangent function. Now that we've solved for tangent function, we will start solving for x, well, for the argument, which is x over 2, and then we'll solve for x. So it's a 3-step process here. He's got it solved for tangent. Where do we go from here? Where do you go from here? Where is tangent? Tangent of what angle is equal to negative 1? Well, these should be pretty familiar to you by now. Tangent of what angle is equal to negative 1? Tangent of what angle is equal to negative 1? Maybe skipping some, but when you, well, it only has sign. There's actually, I suspect some of you have these. But the first place going backwards that I found you could find this, what you need is in 4.6 on page 310. There's a table, but I was trying to find a more general table. I know that it's in here somewhere, I just can't remember exactly. Ah, here we go. Page 293 is another general table that has only the positive values, because they were talking about reference angles. All right, tangent of negative pi fourths is equal to negative 1. That's what I was looking for. So therefore, this says that x over 2 is equal to negative pi fourths. Okay? or at least that's one of them. But since we're not restricted to some portion of the domain, we're going for all of them. So what's the period for tangent function? Pi, you're absolutely right. So we would put plus n pi. That covers them all. Okay? So we do have negative pi fourths is in the fourth quadrant, not the first quadrant, in the fourth quadrant, the place where the tangent is equal to -1. Okay? But we're really looking for x. We're not looking for x over 2, so what would we do next? And this is basic algebra. No real important trig stuff in here. How would you go from x over 2 to x? What would do that for you? Say again? Multiply both sides by 2, absolutely. Multiply this by 2 and multiply each of these by 2. Okay? So this will wipe out your denominator and have x equal minus, and the 2 will go into 4, minus pi halves plus 2 n pi. All right, that's it. Now, if you don't like to be negative pi halves, you could call that, negative pi halves is down here, you could call that 3 halves pi. Well, it's the same thing. If you prefer a positive number, 3 halves pi plus 2. Just like you could have said this was a -1 at 3/4 pi. That would be the same thing. So either negative pi halves plus 2 n pi or 3 halves pi plus 2 n pi. The book chose with the 3 halves pi. I actually prefer you going this way, but it doesn't matter. Both of them are correct answers. All right, there is a checkpoint there, especially since that took so many pulling of teeth to get that out of you. Are there any questions on that before I erase it and go to the next one? Any questions? All right, let's go to the next few slides. All right, using inverse functions. Frankly, we have been using inverse functions, we just haven't called them that. When we say what angle is the tangent of what angle gives you a -1, you were doing an inverse tangent, whether you realize it or not. Okay, so here's example 9. Uh-oh. Here's the original equation. What in the world can we do with that? What's a problem with that? You have 2 different trig functions in it. And like Kamari did before, he isolated a trig function, but that's when you only had one. Here we have 2 different ones. So you've got to get either secants to tangents or tangents to secants or something. What would you suggest you do? What would be your recommendation? Second? This is on page 370, chapter 5, section 5.3, example 9, top of page 370. Okay, it really is helpful to get to know these identities. That's what's going to be able to either get you from secants to tangents to secants, or everything to sines and cosines or something. You got to use your identities. Which one do you think might be the best?
The 1 plus tangents where they equal secants.
All right, up a good old Pythagorean identity that secant squared is 1 plus tangent squared x. Then that's for secant squared, okay, minus 2 tangent x is equal to 4. Okay? What would you do next? Yeah, that means crossing an equal sign, though, so you got to move something somewhere first. See, the tangent square and tangent can't be combined because that's two different powers. Okay, you certainly could do that. However, this is a quadratic expression, right? Do what? Okay, take it out on the date? Okay, never mind. Okay. Just kidding. Okay. What we want to do is write this for quadratic equations. You want to set everything on one side and the other side equal to 0. So if you can factor it, you could use a zero product rule, right? That sounds like it. And rearrange. Because when I have a quadratic, I like the quadratic term coming first. So I'll say tangent squared x minus 2 tangent x. And if we subtracted the 4 from both sides, that was going to be but move it over here. What would it be? Minus 3, and now it's equal to 0. Now let's see if we can factor that thing. Okay? Again, like Kamari was doing before, we're solving for tangent, the trig function. Now that we got it all in terms of one trig function, we can solve for it. If this is factorable, how would it factor? First one factors as tangent x times tangent x. Tangent x is not tax, okay? Tangent x, okay? Then where do we look next? The sign of the last term is a minus, so that means these two have to be different. So one's plus and one's minus. Now, and what's the only possible factorization for 3? Okay, which goes with what? 3 goes with the minus sign, and the 1 goes with the plus sign. You can stop and FOIL it just to make sure. Tangent times tangent is tangent squared. Minus 3 tangent x plus tangent x would be minus 2 tangent x, and then minus 3, yes. It factors. It factored correctly. Now what do we do? Set them both equal to 0. I was going to clean up my sloppy writing there, and of course it erased the part I didn't want it to erase. Okay, so tangent x plus 1 equals 0, or tangent x minus 3 is equal to 0. And where from there? Subtract 1 from both sides of the first one, and you get tangent x is equal to negative 1. Or add 3 to both sides, and that gives you tangent x is equal to 3. Now, I know we're all right with this one, aren't we? Please say yes. Why? Better reason. Because what?
It's one we should know.
And in fact, you did know it about 15 seconds ago. Yes, of course. This will be x equal negative pi fourths. Plus n pi, because they didn't put any restrictions on this, and so we'll just leave it like that. But this other one is not one we necessarily would know. So what do we do with that? Or maybe we should know it. Let's think about that. Tangent is, let's draw us a little picture here. We'll be in the first quadrant, okay? What is tangent defined in terms of x and y's and r's? Y over x, excellent. So this will be 3 over 1. So your y is 3, and your x is 1. So your hypotenuse is going to be the square root of 10, isn't it? Yeah. So square root of 10 is just a little bit more than 3. So it's going to be a 3 circle. Ooh, that's a pretty ugly circle. But it's going to be something like this. 3, 1, and square root of 10. Nope, we don't know anything on that angle at all. Okay? If it had been square root of 3 over 2 or something like that, yeah, we could have known that. Not this one. Okay? So, what do we do? Look at the title of the problem. Example 9. Read it. It's on the board. What does it say?
Inverse function.
Oh, yes. Okay. So what we would do is with your handy-dandy little calculator, we do the inverse function of both sides. Chevette is here. Okay. Now, since we've got a couple more people here, let me go over a pretty major problem coming up next week. Okay? Tuesday morning of next week, 1 week from today, I have a doctor's appointment at 11 o'clock. My hematologist only sees patients on Tuesday mornings. So it's the only time I can see him. Okay? I had tried to set it up for spring break week, but he was on spring break, so they moved it to next week. Okay. Now, it's at 11, but I have to be there for blood work at 10, and I have to leave here by 9:15. Lights out class completely next Tuesday. I would like to make up that class for you because that's my fault, not anything with the school. Here's the even worse news. Next Thursday is Honors and Awards Day at 9 o'clock on the Birmingham campus. No way this class can meet at all on Thursday. So, sometime or another, I'd like to make up at least one of those two classes. If you want to make them both up, I'll be glad to do both of them. But I definitely feel like we ought to make up my doctor's appointment. Now, I went over with everybody else, but let me go over them with you too. On Mondays and Wednesdays, I have free time between 3:15 and 5:15. So Monday or Wednesday, 3:15, 5:15, anytime in there. There's 2 hours there. We can pull out an hour and 15 minutes. Okay. Tuesday or Thursday, I've got any time from the end of this class, 10:45 until 1:15. So there's plenty of time in there to do it. Okay. And then Friday, usually 7:45 to 1 o'clock. So there's plenty of time that I could do it then. Except not next Friday. This Friday would be fine, but next Friday's not because I have an infusion next Friday at 8 o'clock in the morning, so I have to be there by 7:45, and it takes all day. So next Friday's out too. This Friday would be fine. Of those 5 possibilities, Monday or Wednesday, 3:15 to 5:15, Tuesday or Thursday, 10:45 to 1:15, or Friday, this Friday, or not next Friday, but the following, some other Friday, this Friday or some other, not next Friday, would be any time between 7:45 and 1 o'clock. Any of those times work for either one of you? Friday, this coming Friday? Okay. Do you prefer Birmingham or Bessemer? Bessemer. What time would work better for you? I'll be here from 7:45 until 1 o'clock. Say again? After 11? Okay. 11 to 12:15, 11:15 to 12:30, 11:30 to 12:45, or 11:45 to 1? 11 to 12:15? Okay. This coming Friday on this campus, 11 to 12:15. Okay. All right. We will use that to make up our other time. Anyone else who can come, please come. Okay. But at least two of us will be here, right? This coming Friday, 11 to 12:15. We'll make up one class. Now, did you want to try to make up both of them? The honors and awards is the school function. I really, that's not my fault. That's the school's fault. So, if you want to make up two, we can try that too. Okay. All right. So we'll plan for this coming Friday, 11 to 12:15. My office is 265, or I'll be here at right at 11 unless I get tied up. So you get me. Normally I'm on Birmingham, but I'll be here this Friday. Okay. All right. So let's see. We're still at this point. Tangent of x equal to 3. How do we solve that? It's not one of our favorite values. So like the -1, we knew that was -5/4. 3 is not one of those values that we know what it is. So what do we do with that? Inverse tangent. Inverse tangent undoes a tangent. Think of it this way. You do inverse tangent of x and do inverse tangent of 3.
It's 71.6.
Okay, that's what you get on your calculator. So x, and are you in radian mode? I'll take it, right? Are you in degrees? Okay, well that would be fine. What was it in degrees? 71.6? Okay. 71.6 degrees, and that in radians would be 1.2, and this would be plus n pi, and this would be plus 180 n. 180 degrees times n. We usually don't do it in degrees, but that is a correct answer, 1.2 plus n pi. Okay? Now, you want to know how they left it?
As inverse tangent.
Arctangent, yeah. They said arctangent, but inverse tangent, arctangent, same thing, plus n pi. Okay. Which is okay to leave it that way too, but since you have calculators, why not use them? But anyway. Okay, so you see how to do it? Can I erase this and you see the actual how they did it? All right. People listening at home will hear this several times, it seems like. This week is a good week. No problems this week. Next week for this class is a terrible week, okay? Because on Tuesday I have a doctor's appointment at 11 o'clock. I have to be there for blood work at 10 o'clock, meaning I have to leave the campus by 9:15. So our trig class gets wiped out next Tuesday. Okay, 1 week from today. The following Thursday, not this Thursday, but next Thursday, is Honors and Awards Day at 9 o'clock on the Birmingham campus. That's going to wipe out this class, okay? And then next Friday, I have an infusion at 8 o'clock, which I have to be there by 7:45, so I won't be on Birmingham campus at all. So what the class decided before you came in, the only date we found that could work for anybody was this coming Friday at 11 o'clock here on this campus, probably in this room. We'll have the makeup class for my infusion. No, makeup class for my doctor's appointment. I don't think we'll have a chance to make up for the Honors and Awards. That's a school function, so I don't feel. Friday.
This Friday or next Friday?
This Friday. Next Friday I'll be in infusion, so it's going to have to be this Friday. Can you do it? 11 o'clock? Huh? Okay. But you and I will be here, right? Okay. So there'll be at least one other person. I'll record it so it'll be out there on YouTube sometime later in the day. Okay. I'll be here till 1 o'clock, but I doubt if it'll be uploaded by then. So I guess I'll stay till it uploads and get it out there. Okay. All right. So this is example 9, the top of page 370. We just did it. Let's back off. Okay. Here was the original problem. And what's wrong with that problem? You got two different trig functions in it. You want to get all one function, and the easiest way to go is change the secant squared to 1 plus tangent squared, because that's your Pythagorean identity that changes secants to tangents, and that will get it all in terms of tangent. So instead of secant squared, we put 1 plus tangent squared, and the other thing they did was subtract 4 from both sides, right? Because since you've got a quadratic function, you want it equal to 0. So get everything on the left, 0 on the right. Now combining like terms, as Aaliyah said, we will get tangent squared x minus 2 tangent x minus 3 equals 0. Well, fortunately, that's a quadratic in tangent, so let's first solve for tangent. We factor the tangents, and that's the tangent x minus 3 times tangent x plus 1. That factors that. Now that's equal to 0, so we can use the zero product principle to set each of those equal to 0. So, and we're going to start with the interval minus pi halves to pi halves. Okay? In fact, in this case, well, no, okay. We'll start with that. And the reason for that, that's where inverse tangent is defined. So that's why I was saying before, I really prefer this to go with the minus pi fourths, even though the book went with 3/4 pi. Remember, I said, really better to go with minus pi fourths because that's in the region of interest. Okay? So, we either have tangent x is equal to 3, which means x equal to inverse tangent of 3, or tangent x equal to -1, which means x is equal to inverse tangent of -1. We know what this is. This is minus pi fourths. Okay? We don't know what angle, the tangent of what angle is equal to 3, so we're just going to leave that as arctangent. Or, as Amber did on her calculator, calculate the arctangent, and it came up with something like 1.2, I believe it was. Okay? So finally, because tangent x has a period of pi, you add multiples of pi to obtain your final answer. So x is either arctangent 3 plus n pi, which is 1.2 plus n pi, or x is equal to negative pi fourths plus n pi. That's your general solution, where n is any integer. Okay. Make sense? So if you don't know the function, the relationship, use inverse function to get it. Now that leads to a pretty interesting applied problem. Okay, it says you can use a calculator to approximate the value of arc tangent 3 or inverse tangent 3. Amber did and found it to be about 1.2, I believe she said. That's in radians. All right, they skip, same on them, the applied problem. And that's example 10. Let's see if I can get a little more space to write. Okay, this will be example 10. The surface area S in square inches of a honeycomb cell is given by capital S, surface area is equal to 6HS plus 1.5 S squared times bracket parentheses the square root of 3 minus cosine theta divided by sine theta. That should be a closed bracket. Okay. Now, this is good for theta between 0 and 90 degrees. Okay, now they're not doing radians, they're doing degrees. So be prepared for that. What in the world are these H's and S's? Well, they draw the picture over here, and mine is really, really, really going to stink. Okay? But get over it. Okay. Here I'm trying to draw a hexagon, because that's what bees usually do. Hexagonal honey cells. Pretty ugly hexagon. Should be a regular hexagon. It sure doesn't look like it to me. Okay? Okay. Too many moving parts here. Something not like that, but similar. Ooh, no. Sort of like that. Okay. That's still not right. Let me take out a few of these lines. Here it's going to erase too much, I'm afraid. Okay. Let me try it one more time. That's pretty poor. But it's something kind of like that. Okay? Now, your H is equal to 2.4 inches. Not only are they in degrees, they're in U.S. customary system. Your S is equal to 0.75 inch. 3/4 of an inch. Okay. Now, if by chance you haven't figured out what's going on here, the 6 HX's, each one of these sides of this honeycomb, there's 6 sides to it because there's a base of 6 down here. H times S is the length times width of that side, so that's your 6HX. HS. That's your lateral side area, surface area. The 1.5 S squared, where's that coming from? Well, basically, it's twice this number. Okay. It's the rest of this area here. Okay. 1.5 times s squared, or at least part of that. Now, we haven't defined that theta. The theta is this angle up here, kinda. There's your angle theta, and this is a really ugly drawing. Okay, and that theta is not from there; it's from the center point here. But there's your theta. Okay, look at your book. Okay, but that then gives you the rooftop effect up here that you have. That ratio there, okay, with the 1.5 s squared. Okay. Take their word for it, that's what it is. Okay, that's the surface area. Where h is 2.4 inches, s is 0.75 inch, and theta is the angle shown in the figure. 5.2, not mine. Okay. What value of theta gives the minimum surface area? What value for theta gives the minimum surface area? All right. Remember this angle theta? Where is it? First one, meaning it's all your trig functions are positive, including the cosine. So the only thing here that has to do with the angle that can be minimized is this thing right here. What would that need to be the very minimum value it can be? If theta is positive, theta is in the first quadrant, cosine being positive, what's going to minimize this? Hint. It's either going to be this extreme or that extreme, okay? Which is going to minimize that? See, the sign, not really going to matter much, those are positive numbers. This is where you can get your minimum. When theta is equal to 0, what's cosine theta? 1. All right, very good. Okay. When theta is equal to 90 degrees, what's your cosine theta? 0. Okay. So if you chose 0 here, that would be kind of like a maximum, wouldn't it? But theta equals 0, where this is 1, that's going to minimize this part. Okay. Now, say that. What's a problem with theta being 0, though? It can't be 0. Okay. But that's going to bring your sign to be 0, or getting close to 0. Okay. Which would be maximizing this. So I take that back. That's probably not going to be the value you want. Okay. So basically what we have to do is figure out how do you minimize this thing here, okay? Because the smaller this isn't going to change, that's not going to change. So this is the thing that you want to have as small as possible. So let's see what we can do to make that happen, okay? And I was going to try to think of an analytical way to doing it without getting into calculus, because this is pre-calculus, okay? And really the only way you can do it is with graphing, okay? And that's what they do here. If you have a graphing calculator, now they do the entire function. Guess what? Minimize this part right here. You don't have to worry, well, 6 times this times that. plus 1.5 times that squared. That's just a number, okay? What we want is to minimize that. And when you minimize that, you're going to minimize the rest of it, okay? So I would start with the square root of 3 minus cosine theta over sine theta and try to find the minimum value for that. If you've got a graphic calculator, try it. If you don't, look in the book. And they did minimize it here. They used the whole thing. And they came up with an X value of 54.73 degrees. 74 degrees, I guess. Okay? So there's not much more you can do with this, with just algebra. If we knew calculus, yeah, we could go to town with this one, but we really can't. Okay, so that's about the only way to do it. So maybe there was a reason they didn't put it on here. Okay. Don't worry, I won't give you one like that on the test. Okay, but that's how you would do it. But with the constrictions we have, you're stuck with a graphical explanation. All right, this almost finishes 5.3. Let's look at the vocabulary. When solving a trigonometric equation, the preliminary goal is to blank the trigonometric function involved in the equation.
Isolate.
Isolate, very good, okay? Solve for the trig function, then solve for the argument of the trig function. Number 2, the equation 2 sine theta plus 1 equals 0 has the solutions theta equal 7/6 pi plus 2n pi and theta equal 11/6 pi plus 2n pi, which are called blank solutions. Right here. Pink print. General solution. Okay, general solution. Okay, number 3. The equation 2 tangent squared theta minus 3 tangent theta plus 1 equals 0 is a trigonometric equation that is of the blank type. See, we're just missing Dejarian, James, and Jasper. Okay. All 3 J's in the name. Okay. What type? Quadratic type, because of the exponent being 2. Okay? Number 4, a solution of an equation that does not satisfy the original equation is called an blank solution. I don't guess it's on the slides anywhere. I thought it was. Extraneous, you got it. That's the one, like if you square both sides of an equation, you have to check your answers, all of the answers, to see if any of them are incorrect. I thought for sure it was in here somewhere. Ah, here it is. It's this one, I think. No.
It's our example
Yeah, I think it's one that we didn't have on the slide set. Sorry. Okay, homework exercises. Then do any of the odds 5 through 9, any of the odds 11 through 23, any of the odds 25 to 37, any of the odds 39 to 43, either 45 or 47 or both, any of the odds 49 to 57, either 59 or 61 or both, any of the odds 63 to 73, either 75 or 77 or both, and any of the odds 79 to 83. Do 85 and any of the odds 87 through 95. Do 97, and then under exploration, think through the true-false question 99, and think about 101 and 103. I don't know if it's of great interest to you, but they do have a website at the bottom that you can use for meteorological data, as in temperatures and things like that. We did some similar to it. If you're interested in that, there's a website there you can go to. Okay. All right. Let's move on to 5.4. Sorry, PowerPoint has been very, very slow today. So, all right. Okay, continuing analytic trigonometry. Now we're going to have some more formulas and identities. These are called the sum and difference formulas, because now we're going to take a function, sine or cosine or tangent or whatever, and add or subtract the arguments, sum or difference of the arguments. And these are going to lead to other identities that we'll need. We'll use the sum and difference formulas to evaluate trigonometric functions, verify identities, and solve some trigonometric equations. Okay? So, let's look at the sum and the difference formulas and how to use them. Here they are. Now, some of these you probably will need, just like you have to with all your trig stuff. Use them often enough that you get to know them. Others of them, though, you can get from the one you already know. Like to me, it's not hard to remember this one. Sine of u plus v is sine u cosine v plus cosine u sine v. Okay? Sine of one, cosine of the other, plus, same sign, cosine of the first, sine of the second. Okay? Pretty easy to remember. Okay? Now, rather than trying to memorize the second one, which isn't hard to do either, but think of this. If the first one's true, then the sine of u minus v should be the sine of u times the cosine of minus v plus the cosine of u times the sine of minus v. Right? Because the only thing that changed was the v, the sign changed. Okay? But what is cosine of minus v? Cosine being an what? kind of function? Is it even or odd? The cosine is even. Okay? And what does that mean about cosine of minus v? Cosine is the same on one side as it is on the other. Cosine of minus v would be the same as cosine of v. Because they're the same on both sides, right? They're even. Okay? So that would just be cosine v. And sure enough, this part is just cosine v. But what is the sign of minus v? Sine being an odd function. So sine of minus v would be the opposite of sine of v, right? Sine of minus v is up here, sine of minus v, sine of v is up here, sine of minus v is down here, is the opposite of minus v. So therefore you would have a negative sign here for that. So sure enough, this one falls directly from that. So no one, you know both. Okay. Now again, this is probably one you'll need to commit to memory. Cosine of the sum of two functions, the two arguments, is cosine of the first times cosine of the second minus sine of the first times sine of the second. Okay? This time the sign is opposite. So then down here it will be opposite. And again, why? Because put a minus v in here, you get cosine v. Put a minus v in here, you get the opposite of sine v, which would make it the opposite of sine here. So sure enough, that's what cosine of u minus v is. Now, it's up to you whether you try to do the tangent or not. What you could do is calculate it from sine over cosine. That's not going to be particularly easy, so I find it easier just to go and remember this one too. Tangent of u plus v is tangent u plus tangent v, same sign in the numerator, but then in the denominator it's 1 minus tangent u tangent v. Okay? 1 minus tangent u tangent v. But then when you put a minus sign in here, because tangent is what kind of function? Even or odd? Odd. So that becomes a minus tangent v. And down here, the tangent of minus v would be minus tangent v. So you flip the signs here. Okay. So what we're going to do is, in example 1, we're going to see how these formulas enable you to find the exact values of trigonometric functions involving angles, sums and differences of angles. So, here's example 1. Does anyone know what sine of pi 12ths is? Is that one of our favorite angles? No, it's not. But it could be developed using either the sum or the difference of two of our favorite angles. Now, what are our favorite angles? Remind me. 0. I'm going to start with pi 6. Pi fourths, pi thirds, and pi halves. Okay? Now, since we're dealing with 12ths of a pi here, I'm going to rewrite these in 12ths of pi's, not these other things. That's still 0. We're not going to use the 0, by the way. But anyway, this would be 2 pi 12ths, right? This will be pi fourths would be how many 12ths? 3 pi 12ths. Pi thirds would be 4 pi 12ths. And pi halves would be 6 pi 12ths. Okay? Now you have a choice here. Obviously, no sum or difference of these two is going to give you pi 12ths, right? But you could do these two or these two differences, and those are exactly pi 12. this will be pi 6, so that won't work. So you get to choose which one of those you want. Pi 4th minus pi 6 or pi 3rd minus pi 4th. I really don't care. Which one? Pi 3rds minus pi 4ths. You're doing the one the book did, didn't you? Okay. So you want to do the other one just to see it? See it gives you the same answer? Let's do those two. You got a smiley face, so let's go for it. Okay? So this will be the same as the sine of the difference of pi 4ths minus pi 6. Agreed? Okay. Well, what does the sine of a difference formula tell you? Sine of pi 4ths okay. Sine of a difference, this one right here. Cosine pi 6. You see? And what sign follows that? SIGN sign. Minus cosine pi 4ths times the sine of pi 6. Okay? Guess what? We know every one of those. Those are our favorite little angles, right? What's the sine of pi 4ths? Square root of 2 over 2. What's the cosine of pi 6? Cosine of pi 6. You need to know these. These are your favorites, remember? Yes, they are. Root 3 over 2. Minus, what's cosine of pi 4ths? Square root of 2 over 2 as well. And sine of pi 6 is 1/2. All right. Well, what is square root of 2 times square root of 3? Root 6 over 4, because you multiply the denominators 2, minus root 2 over 4, which would be root 6 minus root 2 over 4. Okay? Now, that's an exact answer. If you want an approximate answer, plug those into your calculator, you'll get one. And if you want to check that, plug into your calculator what the sine of pi 12 is and see how close you get. I think it'll be indistinguishable from one another. Okay? All right. So root 6 minus root 2 over 4. If you'll note, okay, remember that, hang on to it. Any questions on it before I erase it? Okay, that's using the first two. The book is going to use the second two. That's also different by pi 12s. Okay? So let's see how they do. They do pi 12s being pi 3rds minus pi 4ths, the one Chevette wanted to use. Okay, but I talked her out of it. Well, let's see what happens there. Consequently, the formula for sine u minus v would be sine of pi 3rds minus pi 4ths. That would be sine of pi 3rds cosine of pi 4ths minus, pi minus cosine of pi 3rds times the sine of pi 4ths. Flip-flopping. Okay? Sine of pi thirds is root 3 over 2. Cosine of pi fourths is root 2 over 2. Minus cosine of pi thirds is 1/2. Sine of pi fourths is root 2 over 2. Multiply those out, you get root 6 minus 2, root 2 over 4. Exactly what we had before, and then you can check that answer. Actually do the math. Square root of 6 minus square root of 2 equals, divide by 4, okay? You should get 0.259 or something close to that if you did it on your calculator. Sine of pi over 12. Then you're also going to get something pretty close to 0.259. Okay. My eyes are getting so dry, I don't know why. There's a checkpoint at the bottom that you can do very similarly to what we just did, only it's a cosine, not a sine. And again, you get to choose either of the two differences that work for you. Now, that was example 1. They are skipping examples 2, 3, and 4, and moving on to 5. Okay. Let's try to get number 2, example 2 done. Find the exact value of cosine of 75 degrees. Whoops, we're in degree mode now. So what are our favorite angles in degrees? I'll start off with 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay? And we've got a 75. Is there any way we can combine any of those together to get 75? Either adding or subtracting. Second? 30 plus 45. So cosine of 75 degrees is the same as cosine of 30 degrees plus 45 degrees. And what's the cosine sum formula tells us? This is the same as cosine of a sum formula.
Cosine of
30 times cosine of 45 minus sine of 30 degrees sine of 45 degrees. Yo! My pen is slipping. Okay. Do we happen to know what cosine of 30 is? We really just did it. If you remember that, what is it? It's square root of 3 over 2. We just did that one when we called it pi 6. That's what 30 degrees is. Times, what's cosine of 45? Root 2 over 2. Minus, what's sine of 30? 1/2. And what's sine of 45? Root 2 over 2. So multiplying the first of these together, you get root 6 over 4 minus square root of 2 over 4, which would be, since you have same denominators, square root of 6 minus square root of 2 over 4. Looks pretty familiar, doesn't it? Exactly the same answer we got before. And the reason for that was, before we were doing the sine of pi twelfths. Anyone know how many degrees pi twelfths is? It's exactly half of pi 6. How many degrees is pi 6?
60.
Huh?
60.
No, pi 6 is
Oh,
30.
30.
Yeah.
30.
And half of that would be
15.
15. Well, 15 and 75 are, what happens if you add them together? 90. So that makes them complementary angles. And the sine of the theta is equal to the cosine of the complement of theta. So, yeah, these are exactly the same values. All right, there is a checkpoint there, too, finding the sine of 75 degrees. And homework exercises here will be either any of the odds 7 through 9. I think you can do all those. And I think you can do all of the odds 11 through 25 as well. And we'll hang on to that, do the rest of them later. Okay. We'll start with example 3 next time.